We'll now do a quick summary for how to revolve around the x and y axis, and then we'll give some examples for revolving around other lines. First, revolving around the x-axis using the washer method. In this case, we're going to integrate from a to b of pi f of x squared minus g of x squared dx. For the shell method around the x-axis, we integrate from c to d of 2 pi y p of y minus q of y dy. While we can use either method whenever we're trying to find the volumes, anytime we're going around the x-axis, our washer method is highly preferred. Next, we'll talk about revolving around the y-axis. If I want to use my washer method here, I'll integrate from c to d of pi p of y squared minus q of y squared dy. And if I want to use the shell method, we'll integrate from a to b of 2 pi x f of x minus g of x dx. So anytime we're going around the y-axis, our shell method is highly preferred. In general, we like to integrate with respect to x. In addition, it is important to note that whatever axis we're revolving around, if we try to use the washer method, that is the same axis we're integrating with respect to. However, with the shell method, we integrate with respect to the opposite variable. We'll now consider this example. If we try to draw this picture, I have negative x squared plus 7 and x squared plus 5. So we have this region, and we're actually going to rotate around the line x equal to 2, which is over here. When we do this, things are going to be slightly different. We're going to start by finding our intersection points. If I do negative x squared plus 7 equal to x squared plus 5, I'll end up with 2 equal to 2x squared, which eventually will give me x equal to plus or minus 1. And I now have to think a little bit about what's going on. Originally, the x in our formula came from the fact that we were finding the radius, and in our shells, the center was the origin. And now that's no longer the case. If I have something like this, and I want to find the radius of a given point, like this one, it's no longer x. In fact, x, or rather, negative x gives me this distance. And to get to here, I have a 2. So in this case, it would actually be x plus 2. And then we're going to deal with our function. We do the top minus the bottom, dx. Simplifying then gives us negative 2 pi times the integral from negative 1 to 1 of minus 2x cubed minus 4x squared plus 2x plus 4 dx. Integrating then gives me negative 1/4 x to the 4th minus 4 over 3x cubed plus x squared plus 4x between negative 1 and 1. Excuse me, that's a minus 1/2. Since we had a 2 there, dividing by 4 gives us 1/2. And once we evaluate at 1 and negative 1, we're going to end up with 32 pi over 3. We'll look at one more example. This time, I have the graph of x squared minus 2x and the graph of y equal to x. And we're going to go around the line y equal to 4. Our first step, this time we're going to use the disk shell method since we're revolving around a horizontal line. That's going to be closer to the x-axis. So the first step is to find our intersection points. If x squared minus 2x is equal to x, I can subtract x from both sides, get x squared minus 3x is equal to x, and then factoring will give us that x is 0 and 3. These are my boundary points. And we now have to think about how revolving around this line makes things a little bit different. And once again, it's going to have to do with the radius. Before, when we were looking at these functions, they were circles or disk. And that's still going to be the case. However, my center is no longer at the origin. For the first one, the total radius is going to be, in general, from this point, since it's 4 up, we have our function value of the bottom function, the distance from this to the center. Well, if I look at a single point, we'll say here, f of x will be the height from the x-axis, and then from here to here, is going to be 4 minus f of x. So if I want to consider the upper radius, I have 4 minus x squared minus 2x squared. And then if I subtract out the other function, well, once again, it's going to be 4 minus this to get to our radius. So we have 4 minus x squared dx. If I try to simplify this integral, I end up with x to the 4th minus 4x cubed minus 5x squared plus 24x dx. Integrating this, it becomes 1/5 x to the 5th minus x to the 4th minus 5 over 3x cubed plus 12x squared between 0 and 3. And evaluating this gives me 153 pi over 5.